Hello everyone, welcome to my channel. My name is Said Ali Abbas and today we are going to discuss what are exact differential equations. So this is over lecture number 7. So far we have learned the formation of differential equations. We have learned separable, homogeneous and reducible to homogeneous differential equations, and now we are going to discuss what are exact differential equations. So let's talk about the concept that is necessary for understanding the definition of exact differential equation. So we will start by the definition of total differential. So we will define what is a total differential of a function in two variables, and then we will talk about the definition of exact differential equation. So we are starting with total differential because it is related to exact differential equations. So the total differential of some function in two variable is defined by df, that is differential of that function f, equals to partial derivative of that function with respect to x dx plus partial derivative of that function again with respect to y, and we have now dy. So this is basically you can say that the definition of total differential. So total differential is given by this equation. It is also called total derivative in some cases. So whenever we have to find the total differential, we need this equation and the terms included in this equation, that is the partial derivatives of function with respect to x and y. So let's say that if we have some function in two variables, let's say if we have a function in two variables, that is x square y square, and we have to find the total differential of that particular function, then it means we have to find the partial derivative with respect to x and partial derivative of that function with respect to y. So first we will find the partial derivative of this function with respect to x, as we are taking partial derivative with respect to x. So y square will be treated like a constant, so our result will be 2x and y square. Now we will find the partial derivative of that function with respect to y. So now x square will be treated like a constant, so we will get 2x square y. Now we will put these values in the definition of total differential of some function f. So the total differential of our function, that is x square y square, I am writing f here, is given by partial derivative of f with respect to x. Its value is 2xy square, so I am going to put this value here, that is 2xy square dx, plus now we have to put the value of partial derivative of f with respect to y, that is 2x square y, so we have to write 2x square y and dy. Now this is our total differential of that function x square y square. Now let's say that the function appearing here, that is 2xy square, is some function m. We are labeling it like some general function m in two variables like x and y, and I am writing dx as it is, and say that this particular function of x and y is some function in generally n, that is also in two variables x and y, and dy as it is. So if you have a differential of some function and that function is continuously differentiable, and like we have here two variables involved x and y, so if this function is continuously differentiable and we got this expression by taking by finding out the total differential. So if we put this expression, this particular expression, equals to the total differential of some function, so if over this expression becomes equal to the total differential of some function, that is partial derivative of f with respect to x dx plus partial derivative of that function f with respect to y dy, then this expression, then this newly formed expression that we have labeled by labeling this function as m and labeling this function by n, then this expression, if becomes equal to total differential, then this expression will be called exact differential. So this will be called exact differential. And if we put that exact differential equals to 0, like if we put our exact differential, that is m function of x and y dx plus n function of x and y dy equals to 0, then this equation will be called our exact differential equation. So this is basically the major concept of exact differential equation. Now one thing more, that you can see if we compare these two equations, over m, that is the function of x and y, m, that is function of x and y, is basically equal to partial derivative of f with respect to x by comparing the two sides. So we get that our function m is basically equal to partial derivative of f with respect to x, and our function n by comparing is equal to partial derivative of f with respect to y. So this sums up the concept or the definition of exact differential equations. Now I will show you the definition of exact differential equation again, and this time it is now convenient for you to understand it, because I have explained each steps and the terms involved in the definition of exact differential equation here. So now you will find it more easy in understanding the differential equation definition. So this is the definition of our exact differential equation. Let's say that if we have this expression, I have explained this expression in the last slide. So this expression will be called exact differential if there exists a continuously differentiable function f on two variables x and y such that the expression equals the total differential df. It means to say that if this expression, that is this particular expression labeled as 1, becomes equal to total differential of some function f, and the total differential is defined by, I have explained in the last slide, the total differential of some function f is given by this particular equation. So if you equal this total differential to this particular expression, if these two expressions are equal, then this expression will be called our exact differential. And after putting these two expressions equal to each other, we can by comparing find out that these results, that our function m is basically equal to the partial derivative of f with respect to x, and our function n is equal to the partial derivative of f with respect to y. I have explained all these steps and these relations in the last slides. So now I am just showing you again so that you get the better understanding. So this is our exact differential, and this is the result we got after comparing these two expressions. And if we put the expression 1 equal to 0, then it will be called our exact differential equation. So this is basically the major theme of exact differential equation. Now in order to start these questions, we have to identify that we have a differential equation of this type, that is we have a differential equation called exact differential equation. For that we have a theorem, or you may say we have a test for the exactness of differential equation. Now we will talk about the test, that how we can identify that the given equation in our case is a exact differential equation or not. So if you have any differential equation written in that form, it will be an exact equation if and only if that particular relationship holds. It means that the function written with the differential of x, you have to take partial derivative of that function with respect to y, and the function written with differential of y, that is n, you have to take partial derivative of that function with respect to x. And if they come up as equal, then you have a case of exact equation. So first we have to identify exact equation through this test, and then we will move towards the solution of exact equation. So now we will see an example, and we are going to solve it, and with the help of that, it will help us to identify exact equation, and it will also help us to learn that how we can solve these type of equations. So here we have an example that is related to exact differential equation. So now in order to solve this differential equation, our step number 1 is we have to identify that we have a case of exact differential equation. And for the identification of exact differential equation, I have basically told you in the last slide that we have a test for the exactness of differential equation. So we will start from this that particular test. So for that test, we have to first identify our m function and n function. So this function that is written over here is basically our function m, and this function that is written over here is our function n. So we have to take the partial derivative of that function m. We have to take the partial derivative of that function m with respect to y. We have to take partial derivative of m with respect to y. So our m function is 3x square y plus 2. So if we take partial derivative of that particular function with respect to y, then x square and 3 will be 3 is constant, and x square is treated like a constant because we are taking partial derivative with respect to y. So our answer will be 3x square, and the derivative of 2 will be 0. Now we have to take the partial derivative of our function n with respect to x, and our n function is x cube plus 3, as we are taking partial derivative with respect to x. So the derivative of x cube plus y will become 3x square, and y will be treated as constant, and derivative of its will be 0. So it is very clear that our partial derivative of m with respect to y is basically equal to partial derivative of n with respect to x. So when these two derivatives are equal, it means we have a exact differential equation. We have a exact differential equation. So it is very clear that in our step number 1 we have identified that we have a case of exact differential equation. So the general solution of exact differential equation, is given by integration of function m dx plus integration of terms in n free from x, and we have dy and equals to some constant c. So in order to write general solution of exact differential equation, we have this general formula. So here we will write the function of m. So the function of m is basically over 3x square y plus 2. So we have to write here 3x square y plus 2 and dx, plus now we have to write the terms in n. It means we have to write down from this function n. What type of terms we have to write down? We have to write down that terms which are free from x, that doesn't contain x. So this particular function n have two terms here. Like here we have x cube, it is obviously x cube, so it is not free from x. So the term free from x is only y, so we have to write y here. So this particular thing means that you have to write terms from the n function that is free from x. So the only term that is free from x in the n function is y, so I am writing down y here. So then we have a differential of y, and that's some constant c. Now we have to integrate these two terms. So I am separating the integral over here. That is, this will become the integration of 3x square y dx plus integration of 2 dx plus integration of y, and we have dy and some constant c. So the integration of that term 3x square y with respect to x, so 3y will be treated like a constant, and the integration of x square will be x cube over 3, and 3 will get cancelled out. So the final answer will be here of this integral is x cube y plus, now the integral of 2 is basically 2x plus, and the integral of y is equal to y square over 2, and here we have a constant c. So this is our general solution for an exact differential equation. So in this way we are going to solve those type of differential equations that satisfy the exactness test for the equation to be called exact differential equation. So if we have an exact differential equation, so we are going to find its general solution by this method. Our step number 1 is to identify that it is a case of exact differential equation. Our step number 2 is that we have to find these integrals, and after solving these integrals we will get our desired result, that is our general solution for the exact differential equation. So this sums up today's lecture. We will meet in next lectures with the other form of differential equation. So thank you so much for being here.